Alright guys, next up is determine net force. So what we're going to do is we're going to be taking a free body diagram, which you have to have before you can start adding up the net force on an object, taking a free body diagram and then determining net force. Now net force just means the sum of all the forces acting on an object. So in this case, we have to take this force plus this force plus this force plus this force, find out what they all are added together, and from there that sum of all of those is the net force. And generally speaking, objects act as if the net force is the only force acting on them. So once we find that net force, we can kind of determine a little bit about their motion and about why they're behaving the way they behave. But for now, let's just focus on how to find this. So first thing is we have 4 different vectors that we have to add here. But rather than focusing big picture on this all at once, let's just pick any 2 vectors and add them. So pick any 2 you want. I would suggest ones that are easy. For instance, let's look at this one, the thrust force and the friction force. They're all in one dimension, which means they're going to be pretty easy to add up. Now notice we don't have numbers here. That's okay, because what we can do is we know that this is the same as this. That's what those congruency marks mean. So since these are the same size in the opposite direction, they actually cancel each other out. So this force plus this force will be 0, which means we can ignore these forces. So now we're just left with, I'm going to sketch this pretty quick, and rather than write out the full name, I'm just going to use these abbreviations. So I've got now the normal force and the gravitational force are the only ones left. But notice these are also in the same line, so they're in one dimension, and they're the same size. So same size in opposite directions. These will cancel out, which means our net force is 0. So there is no net force in this case, because when we add them up, they all go away. Alright, now let's look at another example. You may recognize this one from the reading assignment. This is a situation in which we have a car resting on a incline, so the car is not moving, and it's sitting like sort of on a ramp, you can almost think about it, which is why the normal force points in this direction. But now that we have a free body diagram, we can find the net force. And all you have to do is just start adding any of these vectors. We can add just 3 straight ahead, but right now we're just good at doing 2. So let's take 2 of these vectors and add them together, and it's really your call whichever ones you want to do. I'm going to start with the force of gravity and the force of friction, and I need to add those 2 forces. So what I do is I'm going to come over here and I'm going to draw them tip to tail. So there's my force of friction, and there's my force of gravity, and if I was doing this really super careful, I would measure these and make sure they're the exact same length. My resultant vector then goes from the tail of this first one to the tip of the second one. So what I've drawn there as a dashed line is the result when I add these 2 together. And so now I'm just going to bring that over here, and I'm going to add that in. And now a kind of amazing thing happens. I've done away with this force and this force. My only 2 that are left are this one and this one. Now if you drew this very, very carefully and actually measured these out, what you would see is that this force is actually equal to that force. So now these are in one dimension, they're in a straight line, and they're equal and opposite in size, which means that just as before in this case, when we add up all 3 of those, we find that there is no net force, which you may start to see as a theme of this unit. So what we're going to do when we get to the, or not this unit, but rather this objective, when we get to the next objective, we'll start dealing with situations where you do have a net force. But for now, it's good enough that you know how to add them. All you have to do is just take two vectors at a time, add them, and then add the next two, and keep going until you're left with just one vector, which we call the net force.